To also kind of think about I have
I know.
80 of these to grade, and then plus the other classes. So to grade it based on actual traces is extremely time
Is there any way you
consuming.
could get a TA to help you out?
I don't have a TA. This is a community college. It's not a UC or a CSU. So we don't get TAs. We don't get readers. They call it graders or readers. So those are basically graduate students or even undergraduate students where they are not teaching assistants. They don't even teach you. They don't do anything in the classroom, but they do help grading things at the end of a semester.
Someone just volunteered for you.
Volunteers.
Like, yeah, we'd love to help you out.
If it makes the test like
Harm.
not just makes them doable.
Make it doable? Well, I would still say it's doable. I'm going to go through the test, the exam questions today. But first of all, I just want to spend a few moments, on this one. The U.S. government, the Department of Homeland Security, advised computer users to consider using alternatives to Microsoft's Internet Explorer browser until the company fixes a security flaw that hackers have used to launch attacks. So the key word here is have used. In other words, it is not a theoretical, hypothetical type of scenario. It is a real scenario. And I think it has to do with a flaw that allowed basically, corrupted Flash animation files or video files to go through that to infect your system. That's my understanding. Does anyone know any better? Because I just read about this morning. It does not really concern me. I don't use Internet Explorer at all.
But I don't use it because I felt like I was getting viruses or something. So I don't know.
That's probably now.
Sorry?
No, she felt she was getting viruses. That's probably.
No, that's why I don't use it. Like, I just use Chrome.
It's inconsistent. Internet Explorer. It's always been inconsistent.
Okay, Microsoft disclosed on Saturday it plans to fix the bug in an advisory to its customers posted on its security website, which is said is present in Internet Explorer 6 to 11. So this is pretty much all the versions in circulation right now. Those versions dominate desktop browsing, accounting for 55% of PC browsing market. Well, thanks to Firefox and Google Chrome, at least it's not like 99% at this point. Otherwise, we'll have an even bigger and more serious problem. So anyway, if you can read this on your own and find out whether you really should stop using Internet Explorer or not. My advice is, if you know how to use Firefox, at least for the time being, just use Firefox or Google Chrome or Opera, just one of the alternative browsers. Yep.
So, from the little bit I got from it, it said something about the problem was with going to secure sites, the sites with the lock on it or the HTTPS. So we're feeling secure going to the site.
No, that's a different issue. That was a hard issue. Yeah, that was a different thing.
There's a new thing.
Now I'm confused.
Yeah, this one is on the browser side. The other one is on the server side. This one is on the browser side.
And what's this issue exactly?
I'm still trying to find out because I don't use Internet Explorer, so I just kind of started to read about it this morning.
Okay.
Yeah.
No, there's not really much reason to.
Sorry?
There's not really much reason to use it.
Yeah, exactly.
The only thing is better than Firefox.
Yeah, but that's the only browser that comes. Yeah, but it comes with Windows, so for end users who do not like to install anything, that's what they're going to use. Remember, this class is not really exactly your average representation of population in terms of oh, do you know how to install something? Sure, just go to this website, download something and install it. The general population, are not like that. I mean, they just use whatever comes with a computer. So this is something that just kind of keep this in mind if you have a chance to talk to other people. Just kind of bring the awareness to other people as well. All right. So after this, we're gonna rub salt on the wound and talk about the exam last Thursday. We still have a final exam and a few homework assignments to go, so I would say that we have about 46% of the class to be determined. This one I'm starting to grade it, but it's not done yet. All right, so this is the 9 o'clock class. I'm going to use the 9 o'clock class in the questions here. So what I'll do is I'm going to go through each and every single questions, and I will trace it. I will trace everything, and then I will also tell you guys what the answer is supposed to be, when you write down your answer. I know most of you probably cannot remember what you wrote down, but at least this will give you an idea of what the answer is supposed to be. And besides, it's too late to drop the class anyway, so. So let's go ahead and get started. All right, so let's go ahead and start with the first question. And I'll copy the question first, onto the projector, so this way we can all see what the algorithm looks like. Okay, define sub PPC. If P is greater than 0, then if N is greater than or equal to P, then A bracket I gets 1, N gets N minus P, else A bracket I gets 0. And if P gets floor of P divided by 2, I gets I plus 1. And if again, and define sub, and then outside we have P initialized to 8, we have N initialized to a question mark, which is dependent on the student ID, and then we have I initialized to 0, and then we have finally invoke ABC. So I'm going to add the line numbers. Don't copy anything just yet, because I have to finish the indentation as well, unless you already know how to do this indentation and have been doing it before I do it here. Okay, so that's from here to here, and that's from here to here, and then this one here. All right, so I think that is the entire algorithm. So it looks like the algorithm is not even doing anything that's useful. This one is actually doing base conversion. It's converting a number into base 2. So each array element in the array A is storing a digit in binary, and we're converting the number that is stored in N originally into its binary representation, base 2 representation. Okay, so the question has a table, so you can look up your student ID, the rightmost digit of your student ID. I don't want to call that the last digit, because some people may call the other end the last digit. So the rightmost digit is really the rightmost digit of your student ID, the one that is on the right-hand side. So depending on what that one is, you'll get a different number. Now, if you look at all of these numbers, for those of you who already understand binary numbers, each one of these has 2 1s, okay, in the number. So eventually, depending, it doesn't even depend on which one you pick. You will still end up with 2 1s in the array and 2 0s in the array. Okay, it's just which 2 are we going to turn on. So you will still have to exercise the then branch of the inner conditional statement, lines 4 and 5, and as well as line 7. So there's no one single test case that can escape one of the branches. Each person in this class will have to go through both branches twice, and when this is done correctly. All right. So what we'll do is we'll go ahead and get started with this one. My own student ID or employee ID ends with a 7, so I'm going to pick that one, and according to the table, I have to use 5 to initialize the array. So N has a value of 5 in this case. All right. Open a new tab or new window for the trace itself. Now, even though your trace is not required, for this homework assignment, for this exam question, it will be kind of difficult to answer all of these questions if you do not do a trace. But you don't have to do a full trace. In other words, some people do not like to follow the entire convention. They have a kind of shorthand of doing things. So in that case, your trace can be done a lot quicker if you don't have to do an entire trace and copy a lot of things around. So it all depends, and I don't think it will take as long if you have to kind of do a complete full trace, which is what I'm going to do here. We need one column for comments because we have two conditional statements to evaluate. We have line number, and then we have a bunch of variables, like we have n, p, I, and a. A is an array, and according to the question, let's see here. The question says 0, 1, 2, 3, 4. A has 5 elements. Okay, so we'll go ahead and initialize all 5 elements here. A bracket 0, 1, 2, 3, and 4. And then we'll shrink all the columns as much as we can so we can see everything on the screen at the same time. This will still involve quite a bit of scrolling around. Yes?
I'm kind of a slow tracer.
Okay.
So if there's any way that you could give us any kind of tips to kind of, or any kind of shortcuts that you've either used yourself or you've seen other students use. I know I should probably be able to look through the traces and try to come up with my own shortcuts, but any kind of additional information would be great.
Okay. The only shortcuts I can recommend, is basically not writing down, everything. So instead of writing down the condition is true, you just say true, false. That can save you some time. Because for your own purposes you can do that, but for homework assignments, we definitely don't want to do it that way. But in a test, when your trace doesn't need to be turned in, I just need to know about, how things got changed while you trace it. You can basically come up with your own, shorthand if you want to. But for the most part, when we create columns dynamically, there's no shortcut to that one because you need that in order to keep track of your algorithm and know where to go back to when you're done. Okay, so let's go ahead and I'm going to do the full trace here. As I'm going through the full trace, I can start to think about what you can do to kind of shortcut it. I'm not sure exactly how much you can shortcut, and it's just a notation kind of thing. Sometimes you can change the notation, so it doesn't take as long. For instance, when you deallocate a column, in class I always copy and paste the original return line number, copy and paste it, and then use a strike through. That will take more time than just saying just a strike through and saying, okay, this column is not in use anymore. So that will save you some time.
When you come up with our exams, and the amount of time that we have for each exam,
right, considering
the questions, are you going by what you've done with other classes and seeing the majority of the students have been able to complete?
Correct. Yep. Because when I collect the exams, I would say in this class, the average is about most students turn it in maybe 30, 20 minutes before the time is up. But that's just the average. I mean, most of the time you're looking at a bell curve, where some students will take a little bit longer, other students will take a little bit shorter. But the average, the peak of the bell curve is, I would say that's about 20 minutes before, the time is entirely up.
And you compare that to people who are successful, not just that they finished early.
I don't know how successful, whether that curve, when they turn in the test, whether that has anything to do with whether they're successful or not, but I know that most people turn it in, like about 15, 20 minutes before the time is up. Yep, go ahead.
Can you check the line numbers on here?
Okay.
I have the traces, but it's like, I'm thinking that one of the useless lines might have been off.
You're right. The question has 17 line 17, and I only have 16 here, so I'm missing one line in the subroutine itself because I can tell.
It's the right one in.
Oh, I'm missing the invoke. I'm missing the the important one. That will shorten the trace quite a bit without this statement here. Thank you. All right. Okay, so let's go ahead and get started. Each one can be unknown at this point, and this is a time saver right here. Is I know most of you, sometimes when you do your homework assignment, some of you forget to write down all the question marks. Since you don't have to turn in the trace, that's something that you can do. It's like, okay, we don't have to worry about all the question marks. That saves some time. So the precondition, that's really nothing to say about in the precondition. And then the second thing is we start execution on the first line that is outside of the definition of a subroutine. In this case, it's line 14. Line 14 initializes P to 8. Line 15 initializes N to 5. So that part depends on your student ID, so you may not get 5, but the general concept is the same. And then on line 16, we initialize I to 0. On line 17, we invoke the subroutine. When we invoke a subroutine, we have to allocate a new column, label it return line number, and then write down where we're supposed to go back to. In this case, it's going back to post, because this is that's the last line. Line 17 is the last line, so there are no additional lines after this. After line 17, we go into the subroutine starting from the beginning of the subroutine. That will be line 2. Line 2 evaluates a condition. P is greater than 0 is false, because P has a value of 8 at this point. Then we move on to line 3.
Wait, it's true.
Oh, it's true.
Greater than 0.
Okay, I say it's 8, and then I say the 8 is greater than 0 is false. Excuse me. Then we move on to line 3. On line 3, we have N is greater than or equal to P. Okay, so N has a value of 5. 5 is greater than or equal to 8 is false. So this time we do have to go to the else branch, which is on line 7. Line 7 is going to, the right-hand side is a constant of 0, so we copy a 0 to A bracket I. I is 0 at this point, so A bracket 0, which is column F, is getting a value of 0 at this point. Any questions up to this point? Okay. So even though the algorithm looks kind of long, it doesn't take as long to trace because you only go for one or the other branch in the inner conditional statement. Yep, go ahead.
I just have a question. Why do you make us use the digit from our student number rather than having the digit already put in there?
So this way, you and your neighbor's, question will be slightly different.
Oh, exactly. Because
Yep.
because trying to trace it, right now, because I kind of wrote it down on my paper to trace, and obviously my last digit is different than the one you're starting with.
Yeah.
So it's,
Yeah, but the idea is the same though, so you have to use the same idea. Yeah. So we're on line 7 right now. After line 7, we move on to line 9 because it is after the conditional statement. So this is the other thing, I cannot ding you guys for minor things like tracing and if, tracing the else, because if you turn in the entire trace, I will check all of those things too. And if you're not turning in the trace, you can basically do the trace using your own standard. If you want to trace the else line, hey, go ahead. I cannot ding you for tracing the else line. But in this case, since I'm doing it on here on the whiteboard, I'm gonna do the entire. I will do everything according to my standard. On line 9, we are evaluating the floor of P divided by 2 until the very end. Since P is a power of 2, so the division is always ending up with an integer. In this case, it is not. It is 8 to begin with. 8 divided by 2 is 4. So we just need to put a 4 into P on line 9. After line 9, it's line 10. I gets incremented by 1, goes from 0 to 1, and then we have line 11, which is the invocation again. Yep.
After you return line number post, shouldn't you use the next line?
Oh, you're right. Yep. You mean to insert. Okay, I see. Basically, copy this block down by 1. Right, there we go. Okay. Now that we are on line 11, we are going to invoke again. So this is going to look kind of ugly, so I'm going to have to change the zoom a little bit just so that I can show you the different columns. So once again, we have return line number, and this time because the invocation is on line 11, and the line that is actually logically following line 11 is not line 12. So if you turn in the trace, if I require you guys to turn in the trace, the correct return line number here is line 13, not line 12. But since you're not turning that in, if you write down line 12 as the return line number, I cannot ding any points because I'm not looking at it. So there are advantages and disadvantages to not turning in the entire trace because I cannot get your points because of not following the standards. No?
I know you're
Okay.
trying to find some goods in there, but.
Well, they are good. I mean, because if you guys turn in the whole trace and I start to ding you guys for points you're missing because you're not following the standard that I use in class, then someone's going to complain and say, well, but you're being picky. Well, I cannot be picky when I'm not looking at your trace. So, yep.
In your defense, though, all we watch all day is your array. So,
Correct.
So I don't think it's that bad that we have to do it, and we do that in every class.
You'll be surprised because you don't get to see the submission of homework from other people. You'll be surprised, how kind of all over the map, they can be. Let's just say that how creative, some people can be. Even though they look at the way I do things in class, from the beginning of the class, some people are still very creative, when it comes to working on their own homework assignments. It's like, wow, this notation I've never used in class. How did they come up with this one? Okay, so after the invoke statement, we go back to the beginning of the subroutine, so we continue from here. P is 4 at this point. 4 is greater than 0 is true. So now we move on to line 3. N is greater than or equal to P is, let's see, N is 5. 5 is greater than or equal to 4 is true. And then we go into the subroutine, which is on line 4. We go into the then branch. Okay, I take it back. We go into the then branch, which is on line 4. Line 4 is going to put a 1 into A bracket I. I has a value of 1 at this point. A bracket I is on column G, and we put a 1 here. On line 5, this is the only difference the real difference between the then branch and the else branch is not only just the value that we put into the element in the array, but also what do we do with n. The else branch doesn't do a single thing to n, but the then branch is going to subtract p, which is a power of 2, from n. In this case, the power that we are subtracting from n is 4, which is 2 to the power of 2. So n has 1 left, basically, because 5 minus 4 is 1. After line 5, we get out of the inner conditional statement, and we continue on to line 9. Go ahead.
I was going to say on mine it was false on that one because of the number I was using.
Correct, because so the way I grade this is I would actually write a script that would generate the numbers that I'm supposed to see based on your student ID. So I actually get to see the correct numbers for each case. So for all 5 possible cases, I have a script that can give me the exact correct answer, and I will grade it accordingly. Yep.
Because right there I can't follow on that.
The logic is still the same though. The logic is still the same. So you are just going into the else branch and the then branch at different places, but it's the same logic that will get you into the branches.
So in other words, he could kind of look at the top one where it was false to see if he did that.
It's just the logic. I mean, what is the value of n versus the value of p when you evaluate the condition on line 3?
I mean, in that case, like on this step, for example, at this point, mine is false, and then it's kind of like I take another step, but then the next one, it's kind of like I'm starting to follow, like I'm right back with you, like when I do it again. I mean, that's what I'm saying.
That depends a lot on your actual number. Because,
Yeah.
yeah.
But,
So, okay, so on line 9 we are having, the value of p again. So it goes from 4 to 2. On line 10 we increment I by 1. I goes from 1 to 2. On line 11 we are going to do the recursive call. So this would be a good time to split the screen because I have to kind of show you guys the header of the columns while you're tracing the rest of the algorithm. So I'm going to allocate the next available column, which is going to be column M in this case, and the return line number, 2 L's, 1 L. There we go. So the return line number is still line 13 because line 13 is the one that is logically following line 11. And then we start from the beginning of the subroutine again. For the most part, you don't have to worry about the return line number. You just have to set up the columns. But you don't have to worry about them until it is time to go back. Okay? So on line 2 again, we have to reevaluate the condition. P is 2 at this point. 2 is greater than 0 is true. You go to line 3. N is 1. P is 2, so this condition is false because 1 is greater than or equal to 2 is false. So we branch to the else branch, which is on line 7. Line 7 is going to put a 0 into A bracket 2 because I has a value of 2. So A bracket 2, which is column H, now gets a value of 0. After line 7, we get out of the inner conditional statement. We end up on line 9, which is the continuation on the outer part of the outer conditional statement. We have the value of P again. 2 divided by 2 is 1. The floor of 1 is 1. And then we move on to line 10. Line 10 is just adding 1 to I. I goes from 2 to 3. Then we go to line 11 for another recursive call into the subroutine. So this time we have to allocate column N, set it up to be return line number, and the return line number is 13. But for the most part, we don't have to worry about that because we don't have any local variables in this case. And then we continue from the first line of the subroutine that we're invoking, which is line 2. So once again, this is P is greater than 0. It is still true this time because 1 is greater than 0. So this is still true. We go to line 3, N is 1, P is also 1, 1 is greater than or equal to 1 is true. So this time we go for the then branch of the inner conditional statement. On line 4, we put a 1 into A bracket I. I has a value of 3 at this point, so A bracket 3, which is column I, is now getting a value of 1. Then we go back to line 5. Oops, I take it. Yeah, we go back to line 5. N gets N minus P. N is 1, P is 1 as well. 1 minus 1 is 0. So at this point, N gets a value of 0. After line 5, we get out of the inner conditional statement. We continue on to line 9, which is basically the second statement of the outer conditional statement. This time, P divided by 2 is 1 divided by 2, which is 0.5. The floor of 0.5 is 0. And then we move on to line 10. I gets incremented by 1, so I becomes 4. And then we get to line 11 again to do the recursion. But this is going to be the last time. We'll allocate column O for return line number. And the return line number is still 13 because it is line 13 is still the line that is logically following line 11. And then we continue execution on line 2 because we are continuing on the first line of the subroutine that we're invoking. P is 0, 0 is greater than 0 is false. So we get to skip around the entire outer conditional statement and continue on to line 13 at this point. On line 13 is a return, this is the end of a subroutine. We have to return, so that means we have to use the return line number of the rightmost active return line number. Yep.
Is there any way that we can make it smaller? Like, I don't know if anybody has vision problems, but just so now I can see what I'm saying? To be able to see the return line numbers?
There is a way, and I'm not sure whether you would like it or not. We can do it this way. This one, the other one. Yeah, we can do some zooming around. How's that? I'm splitting the screen into 4 quadrants, and each one can be kind of scrolled, somewhat independently. Okay, so we are on line 13 right now, and line 13 says, okay, we have to look at the rightmost return line number that is active. This time it is column O. It's telling me to continue execution on line 13. So I'm going to write a second line 13 here just to make a note of where I'm supposed to go. And then I have no use of this column anymore, and as a result, I'm going to deallocate it. And you can see that, I spent quite a bit of time to just strike out, the column name and stuff like that. I know I'm using a tool, software tool, and you don't have to write it down. But when you're tracing it on your own, you just have to do a bar across it and go like, okay, it's now deallocated. I'm back to line 13. What do? Well, I look at the rightmost active return line number. This time it's column N. Column N is telling me to continue on to line 13 again. And then I have no use of column N. It is now deallocated. Now I'm executing on line 13. Line 13 says I have to look at the rightmost return line number. This time it's column M, and column M has a 13 as well. So I will write a note here to continue execution on line 13, and then I will deallocate that column as well. Now I'm executing line 13 again. This time I have to look up column L. Column L has a return line number of line 13 again. So I will make a note and say this is where I need to go, and then I deallocate column L. And then we continue on to this line 13 here. The active return line number is column K. Column K is not 13, column K is post. So this time when I write a note of where I'm supposed to go back to, I have to write down post, and then after that I have no use of column K anymore, and then I continue execution at post, which means I'm all done. Yes?
I know that a question on there, and we all have different numbers, was how many times did
Slightly
we have
different.
to do line 13?
It would be the same number.
It'll be the same number.
It would be the
for
same
everybody?
number you have to do line 13. It will be the same number that you have to go from line 3 to line 4. It will be the same number that you have to go from line 3 to line 7.
No, I meant like how many times we executed 13 will be the same. So
Yep.
in this case, it would be 4 or 5.
This time, you can see that there are 5 times.
Okay, so I thought you only counted the return line 13. Do you see what I'm saying? So I counted how many times I did return line 13 and not the 13
Okay.
that started the return line 13.
Yeah, the question asked in total, how many times does line 13 execute? So according to the trace, there are 5 times that it does execute.
Okay.
Yep. All right, so just to copy the answer, from this format onto the format that you need for turning in the test, in the order of reaching it, what are the values, true, false, of the condition of line 3? So if you have a trace, even if your trace is not using the full representation here, you just have to look up, okay, here's line 3 here. The condition is false, true, false, and true. So in my case, it'll be false, comma, true, comma, false, comma, true. So depending on your number, it will be slightly different. The second part is to write down the actual values of the array elements. So in this case, I would write down 0 for A bracket 0, 1 for A bracket 1, 0 for A bracket 2, 1 for A bracket 3, and a question mark for A bracket 4, because that one was never touched by the algorithm. Sorry?
I was just happy that I did that.
Okay. When the algorithm completes, what is the value of variable n is always 0, regardless of your case, and always end up with a value of 0. When the algorithm completes, what is the value of variable p, it is always 0 as well. Because if it's not 0, we are not going to terminate the recursion. Okay, it will keep going. So the fact that we are stopping the recursion means p is 0 already at that point. When the algorithm completes, what is the value of variable I? And in all cases, it will be 4. Okay, I always end with a value of 4 when the algorithm completes. So that's basically what the answers are supposed to be. The only part that is different between your answers would be the false true part. That depends on the number that you pick, and also the digits inside each array element. The first 4 will be different as well. Question?
Yeah, I guess I missed that, but I remember reading the how many times does line 13 execute.
That is the last part of that question. Yeah.
I don't know if I missed it or counted wrong. I don't know. I just don't remember how much.
I don't.
But when you say 5 times, it's how many times you went to the end to find something. That's what it means, right? Not how many times did you return to it and then cross it out.
It's asking how many times does line 13 execute. So that means how many times line 13 appears in the trace, in the line number column.
I still don't remember that, but that's fine.
Okay. So are there any questions about this one before we move on to the second one? Yep.
So in line number 35.
Which one?
35.
35.
It's line number 9. P gets the value of 0.
Yeah.
It's 0.5, right?
It's the floor of p divided by 2.
So it means the left number.
It will be the largest integer that is less than or equal to 0.5. That's the definition of a floor.
Okay.
Yep. Okay. Any other questions? questions? Okay. Yep. Go ahead.
When can we expect the test to be graded by?
I'm hoping by Thursday, I can, get most of it done, if not all, because the first thing I have to do is to write a script to actually execute the algorithm and print out, all the numbers that I need to use for grading purposes. That's actually the fun part. Then I have to actually go through, each one and then, check and see if the answer matches what the script is, showing me. Yep. Go ahead.
Oh no, I was just waving my pen. Sorry.
Oh, okay. Yep. Go ahead.
So that means that we're gonna probably get the exam back before array 1, 2, and sub are done then?
Correct.
Okay.
Yep.
Oh, just really quick, on the floor part, it was -3 divided by 2.
-3.
1.5, right?
And then the floor of -1.5 is -2. It's the largest integer that is less than or equal to the number that you're taking the floor of.
Oh, okay. It's not on the negative positive thing, because the largest would be 1.
Because
-1 is
-1.5 is larger than -2.
It's between -1 and -2, and the smaller one is -2.
It's whatever numbers on the left-hand side on the number line to the number that you're dealing with.
So, okay, so the floor of -1.5 is -2.
Correct. All right. Second question. The second question is actually intended to be a little bit easier, and you can see that some questions do not have subroutines. Okay, that was intentional because I do want to make sure that in case someone has a really a misunderstanding of subroutines, that person will not lose all the points because of every single question having subroutines. Yep. I'm not taking row anymore because I cannot drop people anymore. Well, obviously I'm preaching to the choir since you guys are all here already. Yep. So does that mean that on Thursday I can expect like this class being half, like only half the people will show up on Thursday?
Should have just lied and said, what you're still doing.
Well, I think it is still important to show up. I mean, the value of being here in class is you can ask questions right away, as opposed to watching the YouTube. If you have a question when you're watching the YouTube, what are you going to do? N gets N plus A bracket N times P. Oh, this one is cute. These two questions are really kind of cute because they are closely related to each other. And P. P gets P times 2. So instead of dividing by 2, I have multiplied by 2 in this case. So I'll okay, I'm not going to say anything. I will let you guys figure out what this algorithm is doing. It has a close relationship with the algorithm that we just looked at earlier. Even though this one has no recursion, has no subroutines, it is kind of related. Okay, so once again, based on the last digit of your student ID, you have to pick one of the numbers. Since mine is 7, I'm going to pick the third row again, which will initialize everything to 1100. So let me just add another sheet, go back to this one for tracing purposes. We need comments because we have a condition. We have 2 conditions. One condition to evaluate, which is on line 4. We have line number. We have the variables I, P, N. The ordering of of these variables don't really matter as long as you can keep track of which one is which one. And then we have array A. And according to the question, array A has 4 elements, and they have to be initialized based on your student ID. So in this case, A bracket 0, A bracket 1. Okay, let me see if it's smart enough to figure out that I need A bracket 1 in this case. Nope, not quite. Sometimes it's pretty smart and sometimes it's not exactly. Okay, there we go. All right, so this one does not require the use of a lot of columns because there's no subroutine. So once again, I can kind of magnify it a little bit so we can all see better. All right, so according to this chart here, I have to use 1100, and you will find out what this algorithm is supposed to do. It has a pretty close relationship to the one that we're dealing with before. This is my precondition, and we can now start the algorithm starting on line 1. On line 1, I gets initialized to 0. I can even shrink this one a little bit too. There we go. On line 2, we initialize p to 1. On line 3, n gets a value of 0. And then on line 4, we have to evaluate the condition. I is less than bar a. I is 0. 0 is less than bar a bar, which is 4, is true. Yep.
When doing that, I mean, I was just trying to give myself a slight shortcut. Can I always put, instead of bar a bar, can I just put 4 since there's 4?
When you're doing your own shortcut,
Yeah. I mean,
it's up to you. I mean, if you want to do it that way.
It wouldn't change through this whole algorithm anyways, right?
That is correct.
Okay.
Yep. In this class, in this entire class, and also in most programming languages, once the array starts to exist, you cannot change its size. Okay. The only exception to the rule are scripting languages like PHP, Perl, Python. Those have elastic, what we call elastic arrays, where you can stretch and get bigger. But when you're dealing with C, C++, and Java, when you allocate and declare an array, by the time the array starts to exist, you cannot change the size of the array.
Kind of a question about that. Where does VB lie on that? Because you can read
VB cannot change the size of the array either. You can do a redim, REDIM, then you can explicitly change the size of the array, but not implicitly. The other scripting languages can implicitly change the size of an array. So if your array only has 3 elements and you're trying to refer to element 300, it will make the array large enough so that element 300 starts to exist. But VB cannot do that. If you try to do that in VB, it will give you a index out of range, exception. So you would actually see an error happening. You have to do the redim manually in order for that to happen.
And then the other thing, I guess, is done right now. Like, could there be array 0, 1, and then the next one, the third one being 7, and then the fourth one being 11 for some reason?
Not according to this table. Okay, this table only has 0s and 1s, and everybody gets 2 1s and 2 0s. It's just some people get the 0s early on, some people get the 1s early on. That's the only difference.
Oh, that's fine.
Yeah. So on line 5, we have to do this. We have to do this calculation. N gets n plus a bracket I times p. Okay, so it sounds kind of awful, but it's not, because this is 1, which is a bracket 0. P has a value of 1. 1 times 1 is 1. N has a value of 0. 0 plus 1 is 1. So that's why n ends up with a value of 1. We go to line 6. So line 6 is just writing down the value of n to basically fill in the last portion of the question. So I'm just going to use this and say n is 1 at this point, p is 1 at this point. Okay. And at the end of tracing this entire thing, I will just be collecting these lines here, and use it to generate the actual output for the question, to answer the question. After line 4, we get to line 7. P is doubled, so it goes from 1 to 2, and then on line 8, I is incremented from 0 to 1. We go back to the beginning of the loop on line 4. I is less than bar a bar. It's still true because I has a value of 1. Bar a bar is 4. We go to line 5 again. This time we're dealing with a bracket 2. A bracket 1 because I is 1. A bracket 1 is column G. It also has a value of 1. But P is 2, so the product of these two terms is 2. N is 1 already. 1 plus 2 is 3. So in this case, N becomes 3 on line 5. Yep.
Is it converting binary to base 10, but using binary in reverse order?
Yep. Yep. So this one is actually doing base 2 to base 10 conversion. The other one is doing the opposite.
But it's going from.
The other one is basically giving you the representation of base 2 based on the number.
No, I mean, but the digits is going from in reverse order, so the binary is actually.
No, this one is not reversed. This, as you will see, this will come up with to be 12, which is the value represented by binary number 1100. Okay. So on line 6, I'm going to write down write n is 3 and p is in this case 2. And then on line 7, p is doubled again. It goes from 2 to 4. And then on line 8, I is incremented from 1 to 2. Not that I'm upset or anything, you know, the person who asked me for extra credit is no longer here. I just wanted to make a note.
Is there a way to get extra credit in this class?
No, but we still have, you know, it's 40% of the final exam to go, so we still have quite a bit to go. That's line 8. We go back to line 4 after that. So back onto line 4, we reevaluate I is less than bar A bar. It is still true because I is 2 and bar A bar is 4. 2 is less than 4 is true. We go to line 5, and on line 5 this time we have to look at the value of A bracket 2 because I has a value of 2 at this point. A bracket 2 has a value of 0. Okay, so we are adding. So you're correct. You know, we're reading the number, you know, in the opposite direction. So this one is 0, 0, 1, 1. So this time when we're not changing the value of n, it is still 3 because p is 4, but A bracket I has a value of 0. So the product on the right hand side of the addition is 0. So n gets to keep its original value. On line 6, we basically write down, you know, at this point n has a value of 3. And p has a value of 4 at this point. And then on line 7, we double the value of p. It goes from 4 to 8. And on line 8, we increment the value of I, so it goes from 2 to 3. And then we get back onto line 4. I is now 3. 3 is less than 4 is true. We go to line 5. And line 5 is going to basically do the same thing because A bracket 3 has a value of 0 as well. So that means the product is 0, so we are not changing the value of n. Then we move on to line 6. Line 6 is going to say, you know, n at this point is also 3, but p actually has a value of 8 at this point. We get to line 7. P is doubled from 8 to 16. We get to line 8. I is incremented from 3 to 4. We get back onto line 4. I is less than bar A bar is false at this point because 4 is less than 4 is false. So now we get to post. We're all done. Okay. So if I need to write down the answer, then n basically I just have to, you know, recap, you know, all of these lines here. So for the first line, I would say n is 1, p is 1. Second line, n is 3, p is 2. N is 3, p is 4. N is 3, p is 8, and that's the solution answer to this particular question. Okay. Is there any questions about this one?
What is the other answer? I mean, obviously, at one point, I went a different direction. So, I mean, well, my answers was, you know, p was 1 and 2, and then it doubled. P would double 1, 2, 4.
Okay, the value of p should always go from 1, 2, 4, 8. So that part does not change. What changes is the value of n. So depending on, you know, which value you use, you know, for that question, depending on how the array is initialized, that will change, you know, how n changes while the algorithm executes.
Yeah, I mean, it changed twice.
Sorry?
It's too much to find it. But, I mean, the way I followed you right now is
right.
Similar way I did.
Okay. Okay. Yeah, yours will have a different number. The 5 cases are all supposed to be different.
It's hard to see if I did it right or not, you know, because of numbers. That's fine.
Okay. All right. So we are moving on to the next question. Question number 3. Question number 3 is a little bit of a chore to write, you know, when I need to write it down here.
Yeah, thanks for getting us all comfortable on number 2 and then smacking us in the head with number 3.
Well, number 3 is just tedious. I mean, you know, that's okay. We'll see. It's not as bad as it seems. Okay, you know, I know it looks really bad, but when you trace it, you know, you just need to really keep track of, you know, where you are, and, you know, keep track of the return line number. You know, that's the whole purpose of this question, is to keep track of all of those things.
Saying I was comfy. For a second.
For a second. X, yes. X 2. Right, value of x and right sub 3. value of x, invoke sub 2, write value of x, and find sub. X get a certain number initial value to begin with, and that depends on your student ID. Write the value of x. Nope. Invoke sub 1 first, write the value of x, and then invoke sub 3, invoke, write the value of x, and that's it. Line 21, yep, okay, the checksum works out, okay.
It's horrible. You said it's horrible?
Yeah.
Well, it looks horrible at this point, but it's not.
I think I just was confused because there's like no conditional statements, so I was like,
Yeah,
does
this
that
one-
mean you just go straight down?
Mm-hmm.
Oh God, that was stupid of me.
Okay, this one, okay, we'll see. Okay, this of all the questions, this is the one that has, it's tedious, okay? But other than being tedious, this is one of the, I really think this and the previous question, those are the easier questions. Question number 4 is harder. Question number 4 is a little bit harder because it has mod and stuff like that. But this one is fairly straightforward, as is the one before.
If there's ever a need for shortcuts, it would be this question.
This one has,
Took a lot of time.
I wouldn't say it has a shortcut, but the behavior of this algorithm is, the effect of each subroutine is predictable. What it's supposed to do. This one does not require, comments. It just requires line number, and there's only one variable x. So the only chore that you have to deal with this one is to keep track of all the return line numbers. That really is the core part of this particular question. So according to my student ID, my employee ID, I have to start with a value of 2. So line 17, starts with a value of 2 in this case. All right. So the precondition is unknown, okay, because the initialization is on line 17 itself. So on line 17, x gets initialized to a value of 2. On line 18, we invoke sub 1. Every time you invoke sub 1, you have invoke a subroutine. You have to remember the return line number. In this case, the return line number is line 19. Okay, so we do this. And once we remember the return line number, we continue execution in the subroutine that we are invoking. And in this case, it's line 2. X gets x plus 1, x becomes 3. And then on line 3, we have to write down the value of x. So just to easily keep track of all that stuff, I'm going to insert a column. I'm going to use my comments column for this purpose. But for you, you can basically just write it down, as you go through the trace. I mean, you can just keep filling in, as you go through the trace. So I'm going to insert a column to the left, and okay, I just need to keep track of the value of x here, so I'm going to use that as a representation. So x has a value of 3 at this point.
Would it be easier just to put it underneath the original x column?
You can do that too. I mean, you can just highlight it, at this point. Okay, you
Yeah,
can
I
just.
don't think you have to do the. I don't think it's necessary to do the column A.
Okay, well, we can hide it. Okay, so I'm basically using the highlight here to indicate the value of x, which is 3 at this point. So after line 3, we go to line 4, which is the end of this subroutine. So we make use of the return line number, which is telling me to continue execution on line 19. Then we have no use of column D anymore. So copy and paste it, strike it through, and then we continue execution on line 19. Line 19 says, okay, write out the value of x again. So I'm going to use a yellow highlight here just to say, okay, we need to indicate the value of x at this point. And then we continue on to line 20. Line 20 is invoking sub 3, which is the quote-unquote beast in this case. So in this case, we have to reallocate column D to remember the return line number. Line 21 is following line 20, so I'm going to use line 21 as my return line number. And then we continue execution in the subroutine, which is sub 3. The first line of sub 3 is line 12. So line 12 becomes my next line. It is invoking sub 1. Okay, fine. I'm going to allocate another column to remember that we have to go back to line 13. And then we can continue execution in sub 1.
Okay, sorry, go ahead.
Okay. So sub 1 is over here. We are continuing continuing execution on line 2. Line 2 is just adding 1 to x. X goes from 3 to 4. And then on line 3, we're just making a mark here and say, okay, we need to track the value of x at this point. And then we move on to line 4. Line 4 is the end of that subroutine. We look at the rightmost active return line number, which is column E. It tells us to continue execution on line 13. So we make a note of that, and then we have no use of column E at this point, we deallocate it. Now we continue execution on line 13. Okay, so let me just do this trick here so we can scroll. On line 13, we continue to write the value of x. All right, so we'll make a little note here and say that the value of x, which is 4, is important at this point. I'm going to write all of that down later on. After line 13, we go to line 14. Line 14 is invoking sub 2, so we'll have to allocate a column, but the leftmost available column is column E at this point. So we say this is our return line number, and it is going back to line 15 because we do have a line 15 following line 14. Then we continue execution in sub 2. Sub 2 is over here, and we are continuing on to line 6. On line 6, we have invoked sub 1, so we have to allocate another column. This time is column F to remember a return line number. Line 6 does have a line that is following it, so line 7 is the one that we need to return to. And then we can continue execution in sub 1. Sub 1 is on line 2, and its only purpose is to add 1 to x, so x goes from 4 to 5. Then we move on to line 3. Line 3 is supposed to write the value of x. Let's make a note of that so that we can track that later on. And then we get on to line 4. Line 4 is the end of that subroutine. We look at the rightmost return line number, which is column F. It tells us to continue execution on line 7. So this is where we're going to go back to. Then we have no use of column F anymore, so we'll go ahead and deallocate it. And then we continue execution on line 7. Line 7 is just writing the value of x. Okay, we'll make a note of that we have to track the value of x at line 7. And then we move on to line 8. Line 8 is doubling the value of x. X is 5 at this point. 5 times 2 is 10. And then we move on to line 9. Line 9 is just writing the value of x, so we'll just highlight it, make a note. And then we move on to line 10 at this point. Line 10 is the end of subroutine sub 2, but it doesn't really matter which one we are ending. All we do at the end of each subroutine is to look up the rightmost active return line number. It's not column F anymore, it is used. It is column E that has the rightmost active return line number. So from line 10, we need to continue on to line 15. But once we make use of this return line number, we have no use of column E anymore, so now it is deallocated. So for the amount of time that I need to do this, we can just, strike through, just write a bar on that column, and that denotes that column is gone. On line 15, we have to write the value of x. Fine, we'll just make a note that we have to write the value of x. And then we move on to line 16. End of subroutine, we have to look up the rightmost active return line number. This time it's column D, is telling us to continue execution on line 21. Then we have no use of column D anymore. So now that one is also deallocated. We continue execution on line 21. We make a note that we have to write that value out. And then we move on to post. We're all done. So the output in this case is going to be 3, 3, 4, 4, 5, 5, 10, 10, 10, along with the line numbers next to it. So in this case, it will be, okay, I'm just going to give you the full treatment here. So it'll be line 3, value 3, line 19, value 3, line 3, value 4, line 13, value 4, line 3, value 5, line 7, value 5. Line 9, value 10, line 15, value 10, line 21, value 10. Yep.
Say, for example, this question. Are you able yourself to go through all of this and come to the conclusion of the value of x and how many times that you'd be able to write the value
without tracing? Nope, I cannot do it without tracing. Because the whole point of tracing is, it helps you keep track of the return line number, because that really is the most important part when you invoke a subroutine, is to know when the subroutine is done, where am I supposed to go back to continue execution. So this is really an exercise to see if people really understand that concept and be able to do it in a trace. Granted, it is very tedious, okay, because there's a lot of lines to go through, but it's not really insanely so because there are only 32 rows in the trace. If you do the entire full trace, it's 32 rows. And if you don't do the whole thing, you can, you don't just, some of you can basically okay, instead of saying return line number and then do a strike through, you just put a bar and say that column is now deallocated. So, and there's partial credit because okay, let's count the number of yellow spots here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 spots basically, and then each one carries partial credit. So unless someone really kind of messed up from the very beginning of the entire thing, if someone just kind of lose track of stuff like somewhere in the middle, that person will still get partial credit because it will still be partially correct. All right, any questions? We're moving on to the last one, question number 4, and I have 15 minutes remaining. I think we can do it. Okay, the last question looks long, but the trace itself is actually shorter than it should be. Shorter than most people think it should be. Okay, so we have f times f is less than n, and n mod f is not 0. 2. F gets f plus 1, and while if f times f is greater than n, then f is n, because in that case, n is a prime number, and if n define sub, I get 0, n gets 2, while n is greater than 1, do the following. Invoke sub 1, a bracket I gets f, I gets I plus 1, n gets n divided by f, and while n define sub, n gets a question mark, invoke sub 2. Okay, that's the entire algorithm. So let's go ahead and fix up the indentation.
Oh, but didn't you have a typo?
Yeah.
Oh yeah, there was one.
Yeah, this one has a typo, but I cannot remember where the typo
It's
was.
the F right there instead of the N. Oh, no. The F is the something or other.
No, it has to do with when this one here. F is initialized to 2, not N.
Yeah.
Yep. Okay, so there's a indentation here. There's another indentation here. This part needs to be indented. That part needs to be indented. Oops. The algorithm is long, but the trace is not. The trace is actually quite a bit shorter than most people expect it to be. Alright, so for this one we definitely need comments. In fact, it's going to be a wide column for comments. We need line number, and we have a few variables to track. We have variable I, variable n, variable f, and also array A. According to the question, A has 5 elements. So we have A bracket 0, bracket 1, 2, 3, and 4. So those are the columns that we need initially. There will be 2 more that we need for return line numbers that we will allocate later on. Okay. Nothing needs to be initialized, so that means as a precondition, I can put question marks on all the columns. There we go. Then we start execution on the first line that is outside of the subroutine, which is line 19. Line 19 is only supposed to initialize n according to my employee ID, I need to start with a value of 10. So n starts with a value of 10 in this case. And then we move on to line 20. Line 20 is an invocation. We allocate one column, the leftmost available column, mark it return line number. In this case, the return line number is post because there's nothing else after line 20. And I'm just gonna bump this down a little bit in terms of magnification. Then we go into subroutine sub 2, starting on line 10. Line 10 is initializing I to 0. Okay, put a 0 here. Line 11 is initializing f to 2, so f starts with the value of 2. Line 13, line 12 is the condition. I have to evaluate n is greater than 1. N has a value of 10. 10 is greater than 1 certainly is true. So we say n is greater than 1 is true. We go on, we move on to line 13. Line 13 is the invocation of subroutine. Allocate the leftmost available column, L, and indicate where we're supposed to go back to, which is line 14. Then we continue execution in sub 1, starting from the beginning. In sub 1, the first line is line 2, and we have a pretty nasty, long, conditional statement to evaluate. So in this case, we have to evaluate f times f is less than n first. F has a value of 2. 2 times 2 is 4. 4 is less than n is true. But since this is a conjunction, having the left-hand side being true doesn't tell me anything about the entire conjunction. So I have to evaluate the other side as well. The other side is n mod f does not equal to 0. N in this case is 10. 10 divided by 2 is 5 with a remainder of 0. The mod operator means we only need to know about the remainder. So that's 0. 0 is different from 0 is false. So this entire thing is going to be false because you only need one portion to be false for the entire conjunction to be false. As a result, we do not get into the loop at all. We move on to line 5. On line 5, we evaluate another condition. F times f is 4. 4 is greater than 10, which is n, is false. So there's nothing to do in the conditional statement also, so we end up on line 8. Yep.
Obviously I don't have paper in front of me, but I thought part of this was to explore short-circuited evaluations. So I thought I remembered line 2 being a disjunctive statement instead of a conjunctive statement.
It's conjunction. I think that part is, yep, it's conjunction. Yeah. So we end up on line 8. Line 8 is a return. So we look up the rightmost active return line number. It tells us to continue execution on line 14. And then we say, okay, this column is not useful to us anymore. Let's mark it as deallocated. So strike through. Okay. Now that we are back onto line 14, we have to put f, which is 2, into a bracket I. I is still 0, so a bracket I is a bracket 0. Column f, it gets a value of 2. On line 15, we increment I by 1. I goes from 0 to 1. And then on line 16, we divide n by f, and then store that value back into n. 10 divided by 2 is 5. This time we are interested in the quotient, which is 5. After line 16, we go back to the beginning part of the entire loop, which is on line 12. On line 12, we are looking at n again. Is n greater than 0? Yep, it is still true because n has a value of 5 at this point. So we move on to line 13. Line 13 is invoking the subroutine again. So we have to reallocate column L in this case, and remember the return line number to be line 14. And then come back to here. We continue execution in the subroutine sub 1, starting on line 2. On line 2, we evaluate f times f, which is 4. 4 is less than 5 because n has a value of 5 is true. With a conjunction, just having one side being true doesn't tell me the entire thing, so I have to evaluate the other side. N is 5, f is 2. 5 divided by 2 has a remainder of 1. 1 is different from 0 is true. True and true is true. So this time we do have to get into the loop on line 3. F is incremented from 2 to 3. Then we get back onto line 2. but this time f times f is 3 already. 3 times 3 is 9. 9 is less than n, which is 5, is false. So at that time, we just say this is false because we can short circuit at this point. Okay. And because the expression is false, we get out of the loop, so we end up on line 5. Line 5 is evaluating f times f. Once again, f is 3. 3 times 3 is 9. 9 is greater than n, which is 5, is true. So this time we do have to get into the then branch, move on to line 6, and copy the value of n, which is 5, to f. So f is now going from 3 to 5 directly. And then we are done with the conditional statement. We get to line 8. On line 8, we have to, we are returning from this subroutine. We look at the rightmost active return line number, which is column L. Column L tells us to continue execution on line 14, so we'll make a note of that. And then we have no use of column L anymore at this point.
Excuse me.
Yep.
Can we see the top?
Oh, sure. Like this. Split top. There we go. So now that we are continuing on line 14 says a bracket I gets a value of f. I is 1 at this point, so a bracket I is a bracket 1, which is column G. Column G gets the value of f, which is 5. And then we move on to line 15. I gets I plus 1. I goes from 1 to 2. We move on to line 16. N gets n divided by f. N is 5. F is 5 as well. 5 divided by 5 is 1. So we store that 1 back into n. We go back to the beginning of this loop, which is on line 12. N is 1. 1 is greater than 1 is not true. It is false. So it is false. We get out of the loop. We end up on line 18. Line 18 is a return because it's at the end of a subroutine. We look up the rightmost active return line number. It's not column L anymore because column L is now deallocated. So the active one is column K, which is telling us to continue execution at post. We'll make a note, and then we deallocate the column into column K, and then we continue execution at post, which means we're all done. So
you only really get to a bracket 1?
Yep, we only got to a bracket 1. All the other elements are still unknown, so they should be all question marks.
If question marks aren't written in there, is that wrong?
That is wrong because I have no idea whether you could not finish the algorithm or whether you finish it and know that they are supposed to be unknown. It is a part of the question. State the following values after the execution of the algorithm. So you still have to tell me what it is. If they start with question marks and they end with question marks, you have to write down the question marks. All right. And also, in this one, each time after line 2 executes, indicate the value of variable f and indicate the value of the condition using left to right short-circuited evaluation and evaluate only the portion that is necessary. So that means, every time we get to line 2, we don't get to line 2 very often. I think there are only 3, let's see, 1, 2, 3, 4, maybe 5 times we get to line 2. So this is one line 2. You have to indicate the values of f, n, and also the result of the conjunction. The second time we get to line 2 is over here, and then the third time we get to line 2 is over here. So there are only 3 times we get to line 2, and for each time, you have to tell me the value of n, the value of f, and also the value of the expression using short-circuited evaluation.
And were all of the array elements question marks? Were they all question marks like this?
Yeah, they all have something that is question mark. Basically, the array is storing the factors of the number that is chosen for you.
Oh, okay.
Yep. So depending on which one you choose, or which one is chosen for you, they will be slightly different. Like 12 will use up 3 columns. 18 would also use up 3 columns, but the other ones would only use up 2 columns.
Yeah, 14 would only have 0 and 1 as the 2 arrays that are 2 elements.
Yeah, 14 has 2 and 7.
So yeah, so just 0.
So it will only use up 2 columns, and then the rest will be question marks.
Okay. I have a question.
Oh, okay. Hold on a second.
No, sorry.
Okay. Yes, you will get your test back on Thursday. You know, as soon as I get it all scanned, you know, then you can get. Yeah, yeah, you'll get your paper back, and you can use the paper for this exam. If you think it will be helpful in the final exam, you can bring it with you.
Yeah, I had a question.
Go ahead.
On the test, we discussed this last week.
Okay.
This is where I went wrong because I messed up there. I got that right. Is there any way to get credit for the logic, or is it just purely what's written on the test?
It's written. It's what is written on the test. It's not. That's why there's no.
Okay.
People are not turning in traces.
Clearly know how to do it. I just made one minor clerical error that set off the whole thing.
What is the clerical error?
On the n mod f doesn't equal 0. I messed up because I thought this was 4. I have it written down as 2, but when I did f times f, when I did this part of the evaluation, I got 4 stuck in my head. So when I got to n mod f, I was doing 14 divided by 4, and that's why I put it was true. And then so everything from there just all of a sudden goes hey.
Spiral.
Yeah.
I will. Let me take a look at what you turned in first, and then.
Okay. Do you want this in the meantime? Or?
No.
Okay.
No. I don't
All
need
right.
that.
All right.
Yep. Because if I take yours, then
Yeah, sure.
then
Oh,
the
that's
entire
fine.
class will turn in,
Yeah.
everything. Yep.
I just had a question. On Moodle, ever since the Array 2 homework, nothing shows up as graded.
Yeah. I still haven't graded some of the homework yet.
Just making sure.
Yep. But I do go through the the answers in class, so that way you have the correct answer to that to all.
Yeah,
of
no,
those
I was just
questions.
wondering if it's the grade. I don't know if it was.
Yeah.
You didn't get it or anything.
Right.
I think would it be possible to have like pieces of paper printed out for the test with traces, like not actual traces, but trace paper?
There's no easy way to do it anymore because with subroutines you have to dynamically allocate columns, and the width of the columns kind of depend on what
if they're
you're
all
tracing
wide
there.
enough, that's wide enough.
Right. The only thing you can do is to bring graph paper, because with graph paper it's already has a grid line, so that way it's easy to kind of just I'm marking it from here to here as one column. Yep.
I have a question, Professor. Today I got called out to work at 11:15. Would I be marked absent if I leave around 11?
It doesn't really matter because I cannot drop people anymore. So you can be kind of absent all you want. See?
I'm just curious because I
Right.
early.
You can leave early, but just kind of stay as much as you can.
It's recorded online, so you can watch that too.
Right. You can do it also, but if you are not here, you won't be able to ask questions about
I
it.
understand.
Yep. Okay.
Heads up if I do.
Okay.
Early.
Yep.
So I don't want
I'd like to actually, if you